Lesson 2.6 is on multiplying and dividing rational expressions, and 2.7 is on adding and subtracting rational expressions. Now, we've already covered multiplying and dividing in the last lesson, but I'll be going over it again, and then we'll be moving on to 2.7 also here. So just a quick review. When you have a rational function, the multiplication is such that if you have a rational expression, p over q multiplied with r over s, then you can multiply numerators together. It's p times r divided by q times s, where the restrictions are that q cannot be equal to 0 or s cannot be equal to 0. And if you are dividing rational expressions, p over q divided by k over l, then you change the division to multiplication and you flip the second fraction. So the restrictions for the division are that q cannot be equal to 0, k cannot be equal to 0, because those are the denominators. Even I would say L cannot be 0 because it's a denominator of the second fraction or rational expression. So let's look at an example here. You have negative 5x cubed divided by 12y multiplied with 4y divided by negative 15x squared. So what you can do in this case is you can take the numbers or these constants and put them together. So you have negative 5 times 4 divided by 12 times negative 15. So you just see those numbers together, and then you have the variable parts. It's x cubed y divided by x squared y. And you can try to simplify the numerical part to lowest terms. So 5 goes into 15 3 times, so 1 5s are 5, 3 5s are 15, 1 4s are 4, 3 4s are 12. And you have a division here, the numerator, a negative sign in the numerator, a negative sign in the denominator. They cancel out. So you end up with 1 over 9. And then for the exponent part, it's x cubed divided by x squared is x to the power of 3 minus 2, and y to the power of 1 minus 1, which is 0. So it simplifies to 1 over 9 x, and y to the power of 0 is 1. So you just leave it as 1 over 9x. Or you could just say it's x over 9. Okay? And the second one, and the restriction here is that, if you see the question, you have a y and an x in the denominators, so that x cannot be 0 and y cannot be 0. Now for question B, it's a division, so you change that to multiplication and you flip the second rational expression. The first one stays as is, so it stays as 2x squared. Actually, you could factor out the 2, take out the greatest common factor for this. So you could take out 2xy, and into brackets goes x minus 2 divided by 3a. And this changes to multiplication, and you flip the fraction, you get 5ab divided by 12. I'm just going to make this like this so it doesn't confuse with the x. 12x squared y. Okay. Now because you're multiplying, you can simplify the numerical parts here. So you have 1 2s are 2, 6 2s are 12, and there isn't anything else you can simplify with. There's 1, there's 5, and 3, and 6. So that simplifies to 5 divided by 3 times 6, which is 18. And then for the variable part, you have xy times x minus 2 times ab divided by a times x squared y. We just need some more room over here. I'm just going to extend that page. So this works out to 5 over 18. The a and the a cancel out. The y and the y cancel out. And you can divide the x by the x squared. So you end up with x with a b and an x minus 2 and an x in the denominator. Okay, and the restrictions are, like, you go back to the given expressions, right? A cannot be 0, and b cannot be 0. And also over here in the denominator, when we flip, we have x and y, so x cannot be 0 and y cannot be 0. Okay, all of them cannot be 0. Let's try some examples. There's definitely much larger expressions that you have over here. If you look at this question A, they're all quadratics except this one here. It's a cubic function. It's to the degree 3. So for the quadratics, we can factor them. The first one here works out to 4. So I've already factored it. I'm not showing the work for it. When you're doing this by yourself, you would, find the product and sum and then factor them by grouping. So there is that work involved, which I'm not showing here, but you would do that and you would factor down to 4w plus 1 times 3w minus 2 divided by 4w plus 7 times 2w minus 3. Okay, so this factoring part is a major part of this solution, which I haven't done. I'm just showing you the work after it's been factored. So you have to know how to do factoring, okay? Now remember, we're going to flip the numerator and the denominator. So these will flip, right? And so the factoring of 8w squared minus 2w minus 15 will be on the top. And remember, I've changed this to multiplication. So you get 4w plus 5 times 2w minus 3 divided by this cubic function, 12w cubed plus w squared minus 6w. You got to factor out the w, and you end up with a quadratic, which you can factor out as 3w minus 2 times 4w plus 3. So now you have certain terms that actually can cancel out. For example, this, I'm going to do that in purple. 3w minus 2 cancels out with 3w minus 2. 2w minus 3 and 2w minus 3 also divide. So they divide to give you 1, so you can cancel them out. And you're left then with 4w plus 1. Oops. You're left then with 4w plus 1 times 4w plus 5 divided by, I don't know why that's happening. Okay, divided by w times 4w plus 7 times 4w plus 3. And that's all you can simplify it. You can't really make that any further simplified. So you can now stop here and state the restrictions. So the restrictions are that to find the restrictions, you're going to look at all the denominators, right? So this cannot be 0, this cannot be 0, this cannot be 0, and this cannot be 0. So each of them have to be equated to 0. For example, if you do 4w plus 7 equals 0, 4w equals negative 7, which means w equals negative 7 over 4. So that cannot happen. Okay, So the restrictions will be that W cannot equal negative 7 over 4, right? And similarly, when 2W minus 3 is equal to 0, you get W equals 3 over 2. So W cannot equal 3 over 2. 4W plus 3 when equated to 0 means it works out W is equal to negative 3 over 4. So you can't have negative 3 over 4. And then the this denominator here also, right? When we factor that out, W cannot be equal to negative 5 over 4. And I think we've covered them all. Negative 7 over 4, 3 over 2, negative 5 over 4, negative 3 over 4. And then there's a W2 here. So then W cannot be equal to 0. And 3W minus 2 cannot be 0. This one here. So W cannot be equal to 2/3. Quite a lot of restrictions. So 1, 2, 3, 4, 5, 6 restrictions. Right? Okay, this is a multiplication. So what we need to do is factor the numerators and the denominator of the first rational expression because they're both quadratic expressions. So the numerator factors out to 2x minus 1 times 3x plus 2 divided by 5 plus x times 1 minus 2x. And that's multiplied with 5x divided by 9x squared minus 4 can be factored as a difference of squares, so it's 3x plus 2 times 3x minus 2. So this 3x plus 2 and this 3x plus 2 cancel out. What else? Is there anything else that can cancel out? I guess the 2x minus 1 that you see here will cancel out with the 1 minus 2x, but 1 is the negative of the other, okay? So the 2x minus 1 you see here will cancel out the 1 with the 1 minus 2x, but 1 is the negative of the other. So what you're going to do is you're going to say, well, I'm going to cancel out this 2x minus 1 and 1 minus 2x and put a negative just to show that, you know, I have accounted for that one is a negative of the other. So in the numerator, you're left with just negative 5x. And in the denominator, you have 5 plus x, or you can write it as x plus 5, and 3x minus 2. It's not too simplified expression. And then the restrictions are x cannot be equal to negative 5, right? So take your restrictions from here, 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 and here, okay? So restrictions are x cannot equal negative 5, it cannot equal, so if you equate the 1 minus 2x to 0, you get 1 equals 2x, x equals 1/2, so x cannot be 1/2. X cannot, when you equate 3x plus 2 equals 0, you get x equals negative 2 over 3, so x cannot be equal to negative 2 over 3. And when you equate 3x minus 2 equal to 0, the last one there, you get 3x equals 2, x equals 2 over 3, so x cannot equal 2 over 3. There's 4 restrictions on the x. Because that was a practice examples we had for multiplying and dividing rational expressions. We're now going to go to adding and subtracting, which is 2.7, and it's the second part. Now to add and subtract rational expressions, just like simple fractions, we need a common denominator. So you remember common denominator from adding and subtracting fractions, right? So the same idea applies here. A common denominator is the LCM, or the lowest common multiple of the denominators of fractions to be added or subtracted. So just to recap, let's just find the LCM of some smaller numbers here. For example, if you want to find the LCM of 2, 3, and 5, what would we do? Well, we would multiply 2 times 3 times 5 and get 30. So if, for example, if you had to add 1 over 2 plus 1 over 3 plus 1 over 5, then the common denominator would be 30, right? And then we would multiply and find out, 2 times 15 is 30. So you'd multiply 1 times 15 and you'd get 15 here. 3 times 10 is 30, so you do 1 times 10 and get 10 here. 5 times 6 is 30, so you'd multiply 1 times 6 and get 6 here. Okay, so that's what we would do. And then you would add up the 15 plus 10 plus 6, and that would work out to 31 over 30, and that is the answer, right? So just an example of how you would add fractions after finding their common denominator or the least common multiple. So if we had, instead of 2, 3, and 5, we had variables like x, y, and z, the lowest common multiple is simply the product of x times y times z. But if we had, in part C, to find the LCM of x, x squared, and x minus 1, would multiply, well, between the two of them, between x and x squared, the common multiple would be x squared, because x goes into x squared. So the lowest common multiple would be x squared times x minus 1. Okay. So let's try it with an example. 3 over x squared plus 5 over x squared minus 2 over x squared. This one's easy because there is a common denominator, which is x squared, and they're all the same. It's easy. You just have to add the numerator. So 3 plus 5 minus 2 will give you 8 minus 2, which is 6 over x squared. So that was very simple. Now, part B, you have 4x minus 1 divided by x plus 2 minus x plus 3 divided by x plus 2. Again, there's a common denominator there, which is x plus 2. So you just add the numerators. So 4x minus 1, but it's in this case minus. Since you're subtracting an expression, remember to put that in brackets so you don't make mistakes with the sign. So when you open the brackets, you get 4x minus 1 minus x minus 3 divided by x plus 2. So the tricky part over here was remember to put this in brackets when you subtract. Now you can add the like terms. 4x minus x equals 3x. Minus 1 minus 3 is minus 4 divided by x plus 2. And that's the answer. Now this one here in part C, the denominators are 4, 8, and 6. So what is the lowest common multiple of 4, 8, and 6? So if you look at the times table, the common multiple that is common to 8, 4, and 6, but is also lowest in value, is 24, right? 4 times 6 is 24, 8 times 3 is 24, 6 times 4 is 24. So we have that as the common multiple. So you're going to find out what they are going to make them all 24 in the denominator. So it's plus and minus, so don't forget that. And you're going to say, okay, how do I get from 4 to 24? I've got to multiply 4 times 6. So this entire expression gets times with 6. 8 times 3 is 24, so this entire expression gets multiplied with 3. 6 times 4 is 24, so this entire expression gets multiplied by 4. So put brackets around it because you have to distribute those into the brackets, so don't forget to put the brackets. So in the numerator here, I have 6 times 3x plus 2. And then for the second expression, I have 3 times x minus 4. And for the third one, I have 4 times 2x minus 1. Okay, so distribute them into the brackets. You get 18x plus 12 divided by 24 plus 3x minus 12 divided by 24 minus 8x minus 4 divided by 24. So now at this point you can put them all together. You get 18x plus 12. The second one is plus 3x minus 12. The third one, remember to put in brackets because it's subtraction, so it's minus of 8x minus 4. So be very careful about that brackets when you subtract. Okay, so 18x plus 12 plus 3x minus 2 minus 8x plus 4. When I open the brackets, divided by 24. You can add the like terms. 18x plus 3 minus 8 works out to 13x, and 12 minus 2, 10, plus oh sorry, this is a 12 here. 3x minus 12, 3x minus 12. So 12 minus 12 is 0, plus 4 is 4, so 13x plus 4 divided by 24, and that's the answer. Okay, we have one more up here. 5 divided by x minus 3 plus 2 divided by 3 minus x. So you can see here in the denominator, they are, one is the negative of the other. So you can change this by writing the first one as is and changing this to subtraction and write 2 over x minus 3. So you kind of factored out a negative from here. So 3 minus x is the same as negative of x minus 3. Back. So 3 minus x is the same as negative of x minus 3. So you took the negative up here, brought it, instead of plus, it became minus, and then the denominator stays x minus 3. So now we have a common denominator, which is x minus 3. And in the numerator, you have 5 minus 2. So it works out to 3 divided by x minus 3. Okay, so that are some examples that we have practiced in this lesson. Now you can try the homework questions for this section.